Okay guys, in this video I will discuss how you can create a rigid structure by using bracing. Okay, normally we know that anything rigid or anything which have less deflection or less rotation means that is something fixed, or fixed support can be created only by using some moment connection in any type of frame. Okay, but in this video I will discuss how without using moment connection you can make a more rigid structure compared to your moment frame by using bracing. Okay, so if you are new to this channel, please do subscribe and also don't forget to press the bell icon so that in future you can be benefited. Okay, so let's start. So at the very first, assuming that you are a beginner, I just want to recap the stability characteristic of any structure. Okay, so let's say you have some portal frame like this, and here each and every joint is a pin joint. Now let's say you have some lateral force. So is it stable? No, it is not stable. It is going to collapse. Why? Because you know that if you have a rectangle which is formed by using four member, it can have infinite number of shape under the action of any lateral load. Okay, so to make it stable, what you have to do, you have to make a more stable shape, and which is the most stable elementary shape? That is the triangle. Why? Because if you given three fixed length, you can form only a single number of triangle. That is why triangular shape is most stable structural shape. So how you can make stable this frame? Just by providing some bracing like this. As you can see here, that to make this unstable frame stable, what we have done, we have simply inserted a diagonal member or a bracing. Okay, and there is another way. What you can do, you can simply make this pin joint a moment joint or a moment connection. In that case also, that is a stable. Okay, so we will use this concept of stability or rigidity in our further discussion. So here you can see practically to form any moment connection or a moment frame, we can either use a small diagonal bracing like this, or you can simply use a moment connection where the flanges of the beams are connected with the flange of the column, and it looks something like this. If this is the column, this is the beam, here this flange is connected with the flange of the column. Why? You know that to carry the moment we need to attach the flange, and these flanges are actually carrying the bending moment in terms of tension and compression. I am not going into the detail because I have discussed this many times in my every video almost. Okay, so this is the moment frame. Now come to the brace frame. Here the brace frame is a really stronger frame, and the brace frame is mainly designed for lateral load. Why? Because under the lateral load, this bracing effectively carries this lateral load to the foundation without hampering the column or the beam. Okay, so that is why the stability under the lateral load of any frame is very much high in case of a brace frame. Now you understand the stability of any structure by using moment connection as well as the using of diagonal member or bracing. Now the question is, who is stronger? Okay, whether the moment frame or the brace frame. So first discuss about the moment frame. So let's say this is a moment frame. Okay, so these connections are moment connection, all the connections are fixed. And if you, let's say you have some lateral load which is being applied at the left side of the structure. Now how it's going to be deformed? Well, here you can see that this is the deformed shape, and here you can see that you have some amount of side sway, correct? Okay, and due to this lateral load, the bending moment diagram looks something like this, and here you can see that the bending moment diagram in the beam is like this, and at the end the bending moment is maximum, and at the middle it's almost zero. Okay, so you can see that if you have used, let's say you are using some ISMB 300 for this beam, and you can see that this portion is stressed to its ultimate value, but the middle portion is not at all utilized. Or you can say that the rigidity of this beam is being used partially. So definitely the rigidity of this moment frame is not 100% compared to its theoretical value. It is not at all 100%. Correct? Now come to the brace frame. So here you can see the lateral load, here it is being applied in the same location, but we have used some diagonal member and it is under the subject of compression. And instead of using this diagonal member in this location, if you use this in this location, in this case, this is under tension. But in both the cases, these diagonal members are subjected to axial load. Okay. In the previous case, here, this beam was subjected to flexural load. Right? That is why the bending moment diagram was something like this, and the material utilization was maximum at the end and minimum in the middle portion. But as these members or this bracing is subjected to axial load, here this member is subjected to loading like this, and each and every cross section of this material is being utilized equally. Right? So you can say that the material utilization in case of a axially compressed or axially tensioned member is almost 100%. That is the reason that the braced frame is more rigid compared to your moment frame. So now it is clear who is stronger. So we can use this concept for our design aspect. Let's say you have a structure which need to be constructed for supporting some equipment. Okay, and in this type of structure the lateral load is not that much high. Okay, it is not like that, but it need to be rigid so that this machine under the condition of acting, okay, when the machine is running at its full capacity, this structure should be so rigid that there is not that much resonance or vibration in the structure. In this case, though we have a very nominal lateral load, we have used the bracing to make this structure more rigid in all the four directions. Here you can see in all the four directions we have used the bracing because the mission is to make this structure rigid. Okay, now you can ask that there is not such big load for which this bracing can be designed. So what is the design criteria for designing this type of bracing? Of course, in this case where the load is not that much high, but the purpose is to make the structure rigid, you can use your code for designing this bracing. And what is the basis? In each and every code, you can see that there is a criteria for maximum effective KL by R ratio or the slenderness ratio. So if you simply consider this 180 criteria or 250 criteria, you will get that the KL by R ratio for bracing is maximum, let's say 180, and the length is known to you, this length. Okay, so length is also known to you. So now you can find out the radius of gyration for this braced member. Now if you go to the steel table, from that table you can pick up any member which support this radius of gyration criteria. So that's it.